Good morning. We are team number 9, Team Nosos. My name is Anthony Rieder. A quick overview of our project. We created an electric fence monitoring system. It's supposed to be a generic fence capable of operating on most outdoor fence configurations. Our customer is Professor Michael Ruane. He owns an orchard in upstate New York. Surrounding his orchard is an approximately 6,000 volt electric fence. It's often visited by unwanted guests, animals, and people alike. So part of our project is a warning system which lets out an audio sound to let people around the fence know that it exists and to not go near it. Another part of our project is a sensing unit. It logs the interactions with the fence that may occur. This includes animals contacting the fence as well as pedestrians on the sidewalk it sits by. So the purpose of our project is to alert nearby people to acknowledge the fence and to document all of the interactions that happen on the fence as long as our system is up and running. This would be to assist Professor Ruane in maybe reconstructing his orchard in order to fortify it against these unwanted guests. The system you see here in the picture, that is our final stage. It's a plug-and-play system which requires minimal installation with an easily accessible interface, and it's convenient to any Bluetooth-enabled device.
Hello, my name is Jonathan Mancini. I'm going to give you a technical overview. So here we, Here we have 2 flowcharts explaining the 2 sections of our project. The first section is a contact detection, which starts off with the power harvesting system. It takes in the 6.5 kilovolt pulse and converts it into a 3.5 DC voltage. And this voltage is used to power our MSP 430. The second part is the instrumentation amplifier. This is connected to side A and side B of the fence. These are wires that are dead wires, so there's no pulse going through them. The output from this ranges from 0 to 3 volts, depending on which side of the fence is touched. This is input into the microcontroller, where it is processed and then exported to the XB. This XB communicates with another XB located in the shock box, which is our data storage unit. Here the data is stored until the user wishes to extract it via text file using Bluetooth. So as Anthony said before, any device will work as long as it has Bluetooth capability. Below this is our warning system, which is again connected to the 6.5 kilovolt pulse. It drops down this voltage through 100-to-1 voltage divider, and then is put into the rest of the warning system circuit, which regulates the voltage to power the buzzer, which gives a loud audio warning. I was also the power harvesting lead, so just to go into a little more detail, the way the power harvesting works is it takes in the pulse train, drops it down to a 2-to-1 ratio voltage divider. This is then put into a large capacitor bank, which stores the energy. This voltage is then put into a voltage regulator, which outputs the constant 3.5 volts to power the microcontroller. There is a Zener diode hooked up in parallel with the capacitor bank to make sure that the maximum voltage that the capacitors can handle and the voltage regulator is never exceeded.
Hi, my name is Ramzi, and my part was the contact detection. My circuit is basically an instrumentation amplifier attached to 2 dead wires that run alongside the fence. And it also, you can see it pictured here, it also has an additional gain stage which makes the output readable by an MSP. The basic functionality of the system is that it identifies if any of the dead wires are touched and outputs 3 distinct signals depending on if it's touching side A, side B, or if nothing is touching the fence. The circuit is battery powered.
Hello, my name is Lorrimer, Mann. I was responsible for the warning circuit in this project. As my colleague said, the warning circuit is intended just to warn people passing by that the fence is electrified and they should not approach it. As such, the main component of this device is just a low voltage DC buzzer. To protect this buzzer from the 6.5 kilovolt pulse on the fence, the input or the electric pulse is stepped down through a voltage divider. It is then rectified and used to charge a capacitor bank. This capacitor bank actually, it charges way faster than it discharges, so the pulse, which is just a few microseconds long, manages to charge the capacitor bank so that it discharges slowly into a voltage regulator, which provides the power for the buzzer, and so the buzzer can create a loud noise that lasts much longer than the input pulse. So the only objective of this circuit is to warn people through audio that they shouldn't approach the fence. But it has the option of being installed individually, independently from the power harvesting system. So if it's installed by itself, it also has a set of bright neon lights that add a visual warning to the system. And the system was also designed with the concern of having a minimal current draw, since this device is connected to the same power line as the power harvester. If the warning system were to draw too much current, then the power harvesting system might perform differently and have inefficiencies. So the system is just meant to draw a minimal amount of current and provide a loud warning and a visible cue in case it's installed individually.
Hi everyone, I'm Glynn. I was the microprocessor and communications lead for this project. The microprocessor used is the MSP430. I chose this because I'm familiar with it. It has good low power features and it has all the peripherals we need for the project, such as an ADC and UART. For the wireless transmission, I chose the XP Series 1. I chose this because of its ease of use. It takes in serial data and broadcasts it on a 2.4 gigahertz radio frequency. There's no real setup to it. And the functionality of my system is relatively simple. Basically, I just interrupt a few times per second. I read in the ADC from the instrumentation amplifier. I process what I read in, determine whether side A was touched, side B was touched, or no side was touched. And then I output this via UART to the XP board, which then broadcasts it to the data storage unit.
And I was the data interpretation and wireless transfer lead. I was in control of the Raspberry Pi board, which we use as a shock box. The Raspberry Pi board is a very simple device that, when it's paired with a Bluetooth dongle like the one we used, is very capable of transferring files fairly easily to a user, as well as receiving the serial communication from the XPs. The Raspberry Pi has two functionalities. It receives and decodes the serial data from the XP to a verbal interpretation that writes this to a text file saying if the side A or side B of the fence was touched at this time. The files are time-stamped and have the side that was touched. The second part of this is the automation of the Bluetooth file transferring. Bluetooth is very widely used. Bluetooth starts at boot. You automatically connect and pair, so the Pi will automatically accept all pairings and connections, and then it will automatically push the fence update text file to the user without any further action. It's a one device at a time system, and you disconnect and then reconnect to re-receive the file as many times as you please. So now we're going to move on to the video. So this just shows a quick demonstration of our project working on a mock electric fence.
For simulated fence, the charger set up over here connected to side A and side B, as well as the ground being connected to the power supply over here. We also have our warning sensor set up here connected to side A, and the ground is also connected to the power supply simulating our goal. This is our warning sensor. It beeps with every single pulse. We have a 10K resistor touching side A, simulating a bare touching side A, and in the back we have our power harvesting, which is also communicating with our Raspberry Pi. Here we have our shock box receiving information from the power harvesting circuit. You see Gnosis as a device. You connect to it in order to receive a file. Within seconds, it should connect. You'll see successful, and instantly it will push the update text file, as you can see, to your computer. You open your folder, and there are your updates.
Right. So in conclusion, as you can tell from the video, we were successful in the aspects of the project that were required of us. We were successful in audibly alerting passerbys of the fence, harvesting the power from the fence to use as a power supply to our circuits, detecting where and when contact with the fence was made, and wirelessly sending the interaction log in an easy-to-read text file to the user over wireless Bluetooth. So we'd like to thank Professor Kia, Professor Pisano, our customer, Professor Ruane, Professor Horenstein, Professor Klepston, Bob Jostrom of the EPIC Lab, the rest of the EPIC Lab staff, because they really are awesome, and the rest of the senior design staff. Thanks for the patience and for letting 5 guys play around with the 6,000 volt charger.
Did you say the instrumentation amplifier was powered by the battery?
Yes, it is.
Why is it powered by battery, not harvester?
I mean, originally that was obviously the plan, to have it powered by the power harvester, and with more time, we think we could have made it work with a power harvester.
The reason it's not is because of the current that it draws. So with such a short pulse, the pulse is only about 60 microseconds. So the current that we were actually drawing wasn't capable to power about 30 milliamps, which actually is required for the op amps in the instrumentation amplifier. So that's why the power harvesting is only powering the microcontroller.
Do you know how long the instrumentation amplifier will be functional with that battery?
It's about 2 days.
2 days?
Yeah.
Professor Quincy?
Explain a little bit more about your instrumentation amplifier and how that does the sensing. You have these 2 inputs which are tied to nothing.
Yes.
And you have dead wires which
The
are
inputs are the dead wires, actually.
the high voltage wires, and then magically you get these signals. Can you explain how that happens?
Magic.
I'll just-
And if you really believe this wasn't the bears, why did you use the 10 resistor? I'm just kidding.
So yeah, V1 and V2 are where the dead wires go in. And once you ground, so the dead wires are actually a huge resistance since they're just hanging there. You can imagine them as like 100 kilo ohms or more of this resistance since they're not attached to ground. Once you touch it, it grounds that part of the circuit and changes the voltage and the output of the system depending on which side is touched.
I guess my question is, what's the signal?
Sorry.
What's the signal?
So there is no input signal from either side A or side B to begin with, so the output is actually just noise. And then once side A or side B is touched, the voltage will change to either 0 volts or 3 volts, depending on which side is touched. And the wires that are in... Correct, yes. Sure.
The shock box has the communication with the computer, correct?
Yeah.
And you're using Bluetooth?
Yeah.
Where is the shock box located? Outdoors?
So it's actually plugged into the same outlet that the charger, the fence charger, would be plugged into outside, some feet away from the fence itself and the other XP receiver.
Okay. And so do you have to go outside to get there?
Yeah, you have to be within, I think it's like a 10-foot radius in order to actually connect to the Bluetooth.
So all the systems are set up outside, and they've all been weatherproofed, so they're constantly outside. Yep.
How much power do you harvest from the fence? Did you ever have a determination of that in terms of wattage?
So the total current aspect that we could receive was never determined, but in terms of the voltage will keep on being stored in the capacitor bank. But right now we're storing 270 microamps and at 3.5 volts constantly to power the microcontroller.
So is that about per event? Is that a continuous harvesting?
It's continuously harvesting, so the microprocessor is on 24/7, as long as the fence is on.
You're keeping the capacitor bank fully charged,
Correct.
but you don't know the current, you don't know the load on the system, so you can't really determine how power you're harvesting.
Well, right now it's 270 microamps at 3.5 volts.
Continuous though.
Yes.
We have a question in the back, or?
Yeah, I'm wondering, is this a constant warning, so the light and the sound signal are constantly happening?
Yes,
Yes.
they go off with every input pulse from the electric fence charger, which goes off about roughly once a second. So that's how often you get an audio warning or the visual warning.
So the second question is, could it be designed so that it only went off when something came within 3 feet of the fence?
Our customer asked it to actually be designed to warn people, not as like a representation that the fence has been touched. So the warning system was kind of separate from the actual detection of an animal coming in contact with the fence.
No, I'm saying something different. I'm saying that if it were a highly developed you could sense from a certain distance, thereby not polluting the environment with light and sound constantly.
Do you have time for
another question?
That's it?
No.
All right.